Welcome to Interesting People. My name is Tom Lorentzen, the host of the show. This is filmed at Chabot College in Hayward, California, under the auspices of the Chabot Los Positas Community College District. The show is based on the premise that there's interesting people everywhere. They don't have to be known or famous or anything like that. And I feel that that's been a truism throughout my life. In the past, I was a former regional director for the U.S. Department of Health and Human Services, and that put me in the senior federal role here in the western states. And I took the approach of raising how do we improve health outcomes, and more so than just medical care and people being sick. That's obviously important. And then I was attending a conference in Washington, D.C., and Bill Nye, the science guy, was talking, and he referenced to the audience, what do you think is the biggest breakthrough in human history to improve health outcomes? So that resonated with an objective that I'd set here when I was working for the U.S. Department of Health and Human Services. And the audience guessed, and I guessed, and we were all wrong. He said, it's sanitation, it's sewers. And that was something I'd never thought about. And so in following that line of thought, that perhaps the key breakthrough in improving health for everybody, not only in our country, but around the world, is the development of sanitation systems and sewage systems. So with that, my guest today is a gentleman named Jimmy Dang, who is the general manager for the Oro Loma Sanitary District here in the East Bay Area in the San Francisco Bay Area. It's based in San Lorenzo, California. And he's not only has very interesting work and very important work for all of us in terms of health, but he's also an interesting guy. So welcome to the show, Jimmy.
Thank you, Tom.
Thank you for being here. So with that said, you're a civil engineer by training, and you have a Bachelor of Science degree in civil engineering from Cal Poly in San Luis Obispo, and a master's degree in public administration from Cal State University, Dominguez Hills. He has 18 years of experience in both the private and public sectors, with a particular focus on the design and management of waste and wastewater systems. Now, to a lot of us, that may sound like something we don't know, that we find boring or not important. Well, I look at it very differently. I think he's one of the most important persons doing one of the most important things here in the Bay Area. So with that, Jimmy, when I reference how important you are and what you do now as the general manager with the Oro Loma Sanitary District, how do you respond to that? Do you feel you're important? And tell us what it is that you do that is important.
Sure. At Oro Loma, we provide collection of sewer and treatment of sewage coming into our treatment plant, along with garbage, recycling, and organic collection throughout our customers in our district. To answer your question, whether or not I feel like this is, sure, it's definitely an important role that I play here, but what the district provides, lost the words.
You're being humble there, Jimmy. It was just a few years ago where I had a backup in my house, and the sewage system wasn't working, the toilet couldn't flush. I couldn't do anything. I couldn't use the kitchen, I couldn't get in my car and go anywhere because it was so important to me. And that's where I come from, is because he's the person who makes things work for all of us. And when you stop and think about it, when you flush your toilet, where does it go and how is it handled? And it's as important almost in many ways, or as equal with fire department, law enforcement, medical care. And that's why I look at you as important, because without you, what could we do? We can't do anything if we can't now flush our toilets. But what is it? So when we, tell us about Oro Loma Sanitary District. How many people do you serve, and what is the audience out there?
Sure. We serve about 180,000 people, which includes the residents of Castro Valley. And what we do is we collect everything that you flush down the toilet, everything that you wash down the sink. All of that comes into our main sewers in the middle of the streets and down to our treatment plant at the end of San Lorenzo. And what we do there is essentially you clean the water that's coming down the drain, remove all the contaminants, and then making sure that we send clean water into the bay, San Francisco Bay.
So from my home or anybody's home, now how many people do you serve?
180,000 people.
180,000. And you serve other districts?
Yes.
Which ones do you serve?
Yeah, so we mainly serve the unincorporated areas in Alameda County, which include Cherryland, Fairview, parts of San Leandro, parts of Hayward, and we bring in we treat all of Castro Valley sewage as well.
I see. So from a home or a business with the human waste is mostly what you take care of. So when we say flush our toilet, it goes into a system then and goes out to the street normally, right? To a common, do you maintain those? Do you develop them?
Yes, we have approximately 272 miles of pipeline underneath the street, underneath the pavement, and we maintain it. We replace broken pipe every year, and we make sure that homeowners and residents can flush their toilet without a backup.
270 miles of pipe. How do you, it's all underground. How do you monitor things like that? How do you know what's working and what's not working?
Sure. We have a collections crew, which is made up of professionals that clean the sewers. So they'll typically access our sewers through the manholes that you see in the street. And they will clean the sewers with mechanical equipment or high pressure water equipment. And also they have a camera that they can run through the system to televise any broken pipe, defective pipe, identify any repairs that need to take place, and that eventually that footage ends up in our engineering department, where they will review the videos and then determine what needs to be replaced, what needs to be built into the next year's budget, and so forth. And then so we have a huge plan for it. Typically our camera footage will be able to see our entire system, all 272 miles, in about 3 years.
Wow. For a person in my age bracket, sometimes I look back and I think of Art Carney and Ed Norton on The Honeymooners with Jackie Gleason, and he worked in the sewers of New York, and it was a comedy, a tremendous comedy. But other than that, a lot of us just don't think about how all this works. So 270 miles of pipes. So the pipes, from a person's home, a person is responsible for the pipe that goes out to the street, right? But then once in the street, then it's your responsibility then from there?
That's correct, Tom.
And so what are the pipes like? What was the original pipe system, and what was it made of, and what is it made of now? Is it pretty much the same, or what's happening there in terms of pipe integrity and capabilities?
Most of the pipe that was installed over 50, 60, 70 years ago are made up of essentially clay. And they have joints every 10 feet, approximately every 10 feet. And over time, when you have the earth moving, traffic on top, in general, the ground shifts. And with that, you can have open joints. You can have joints that open up. You can have pipe that will crack, break, or even a hole could form. And typically, if there is a hole that forms, the public will typically hear about it if the hole is there long enough and develops a sinkhole.
Yeah.
So we, as a district and our crews, try to get out there at least on the 3-year cycle. Some pipes tend to have a higher frequency of inspection than others, depending on how quickly the pipes get damaged. But overall, our system is made up from a minimum of a 6-inch diameter clay pipe, if you can imagine, just about that big, to a 72-inch diameter where you can literally walk through the entire pipe.
What's like in the street, what's the size of a normal pipe in a residential area?
Anywhere between 6 and 8 and 10 inches in diameter.
6 and 8, 10 inches. And are all those still clay pipes for the most part, or?
I'd say for the most part, they are still clay. We have been replacing, as we replace damaged pipe, we replace it with HDPE, high density polyethylene pipe, which essentially is a type of plastic. And that pipe could last anywhere over 100 years, which is why we select that pipe to
Wow.
go in the ground in place of the clay.
Are there any environmental concerns with that type of
No,
piping? No.
no, not at all.
Well, I know when I had a problem at my home a few years ago, the lateral, as they called it, from my house to the street was my responsibility. And how, again, couldn't do anything because if you can't flush your toilet, you're not going to do anything. And so was able to get a company, and they came out and they came to my home and they ran a camera into the lateral. And they identified with this camera a crack in the piping from my house to the street, which was my responsibility. Tell the audience here and myself about these cameras. Is this something new, and what's the history of these? And
Yeah, they're not necessarily new. The cameras are typically, they have an articulating head in the front, so they're on wheels, so you can drive them into the sewer pipelines. And in the front, the camera head allows you to rotate it up and down, left and right, 360. And as the camera operator runs this camera through the sewer system, they note all the defects. And as they note the defects, it gets put into an actual report that, again, as I mentioned earlier, goes back to the engineering department. The way we replace pipe is no different than how your lateral was replaced with another type of plastic. We call it a trenchless technology. It doesn't require you to dig up the entire street from manhole to manhole. All you need to do in our case, in some cases, is open a pit near a manhole. Let's just use the average, go 300 to 500 feet down the street to the next manhole, open the pit there, and essentially what you do is you pull in the new pipe in place of the old pipe.
can you do that with the pipe in the streets too, the larger pipe?
Yes,
So you
that's
can do
exactly what we do in the streets.
that. Yeah. Now, you say manhole covers, so do you actually have individuals actually where there's a manhole would go down and inspect things too anymore?
We typically try not to have our crews go into the manholes themselves. We try to engineer that out because, as you can imagine, it's a confined space and it can be a dangerous environment down there. So we try to operate as much as we can from the street.
When was Oro Loma Sanitary District, when was that formed? Where I live in the town of Castro Valley, which we know where that is, some of the audience may not know where it is. It's a town now of over 60,000 people. And the first governmental entity formed in Castro Valley was the sanitation district in Castro Valley. Then came the schools afterwards. And that always intrigued me. So sanitation came first, then the schools. I mean, there were a couple of schools, but they never had a district there for schools until after the sanitation district. And that was one of the things that I first started wondering about is, well, sanitation came first and schools second. Wow, that's not what I would have thought would be the case. And before there was the law enforcement agencies there locally. And so you serve, you said 180,000 people, you have 270 miles of pipe. And how many employees again do you have in your district?
We have 46 employees in the district.
That seems awfully small compared to what you have to oversee with all these miles of pipes and all the people you serve. How do you do all this with such a small number of people?
Tom, we're very efficient.
And that's why you're by the way, congratulations. I knew you were the interim manager and you've just been confirmed or picked to be the permanent manager. So congratulations on that too again. Okay, so this is the Oro Loma district, sanitary district that serves 180,000 people. With the San Francisco Bay Area, I'm not sure what the population of the entire Bay Area is, I'm going to guess probably 5 million, give or take, maybe. So this 108, how many districts do you know offhand are there in the whole San Francisco Bay Area?
I'm not sure how many districts there are, just because there's different types of agencies that that serve different entities. But overall, there's about 37 treatment plants in the Bay Area.
37, wow. And these, and we're going to get this in, further into the subject a little bit further in terms of the whole treatment process here. So, but there's 37 treatment plants. Now, do all these, where does it eventually end up in San Francisco Bay?
It does.
That's hard. It's hard to imagine how all this happens with all these. If there's 270 miles of pipe in your district, there must be, several 100,000 miles of pipe in the entire San Francisco Bay Area.
Easily.
Yeah. Wow. The logistics, when President Kennedy became president, he made a scientific target. He said, I want to put a man on the moon. We'd now say a person on the moon. As Jackie Gleason would say, go to the moon. And that was considered so impossible to put a man on the moon, and all the logistics, all the science and all that. But what you do is tremendously complex too. I mean, with all this labyrinth of the piping and all the things that are brought into play, it seems to me that you do science, you do biology, you do chemistry. So what type of people work for you? Do you have a whole diverse background of people with expertise in different areas?
Absolutely, Tom. We have anywhere from administration to operators who are licensed in wastewater treatment who operate our treatment plant. We have a collections crew that I mentioned earlier that goes out and maintains all our sewers and inspects all our sewers. We also have a maintenance crew that maintains the treatment plant whenever there's repairs or failures in the equipment. We have a plant chemist. So there is someone of a scientific background, if you will, core education in science, who has a background in chemistry and biology. We also have an engineering department, and those are typically made up of engineers with 4-year degrees in engineering or has a construction background. Of course, we have our admin staff as well, from accounting, finance to HR. So you can basically name anything in a typical company or role in a typical company we'll have here as well.
In your background, you're educated in civil engineering. How did you end up gravitating into this line of work? Any particular thing happened that made you go in this direction and not in that direction? And
yeah, funny you asked that, Tom. Simply put, I just needed a job.
Yeah, I know what that's like. I had to. Yeah.
No, all kidding aside, I actually came out of school, started off in construction, working for a general contractor. And we were building hospitals at the time. And with the civil engineering degree, I still remember my first year professor telling all the students in the lecture hall of over 200 kids, 200 students, saying, no matter what you do, make sure you go get your engineering license. And that's a state-issued license to practice engineering. And so when I was with the general contractor, working for them for about 1.5 years, I realized that I wanted to pursue my engineering license at the time, even though I had my degree, and had to go work for a company that had licensed professional engineers on their staff. So that's when I literally fell into water, wastewater. I joined the design firm in San Francisco, working in this type of work, designing and constructing, mainly designing and managing water and wastewater facilities, design of those facilities for clients, and then did that for about 5 years, obtained my engineering license from the state, and then now work for the public sector.
I see. Ever since 9/11, we all have become aware of the importance of first responders, law enforcement, fire department, et cetera. And yet, I mean, that's what we identify as first responders. Do you consider your Oro Loma and people that work in this area to be first responders as well in terms of your responsibilities?
Absolutely, Tom.
When something happens, do you say if it's in the middle of the night? How do you address something that then would be, say, an emergency situation?
Yes, so at our plant, we staff the treatment plant 24/7.
20%.
And as far as anything that happens in the streets, if there's an issue with a manhole or sewage in the street, we have our staff on call to respond at any given moment.
Do you interact with local law enforcement, public health agencies, fire department people as well?
Yes, absolutely.
So they know they can call on you at any time when they identify this as the...
Yes, we're on their emergency call list. If there's ever a sewer or manhole, sanitary sewer issue, we're on the list to be called.
And, you know, to the audience out there, excuse me, we're probably going to insert some things in here because your website at Oro Loma, you have a lot of great video there, and we're going to probably add in some video at different times in here to augment the wonderful things we're learning here from Jimmy. Jimmy, I think we're going to take a short break here now for a public service announcement, and then we will come back here in just less than a minute or so.
I know kids worry about a lot of things. Getting enough food to eat shouldn't be one of them. Through a nationwide network of food banks, Feeding America serves virtually every community in the United States. See how you can help your community. Visit feedingamerica.org.
Hello, I'm Tom Lorentzen, host of Interesting People. Welcome back after our brief break here. My guest today is Jimmy Dang, who is the general manager at the Oro Loma Sanitary District here in the East Bay area of the San Francisco Bay Area in California. We talked a lot about the sanitary district, the role it plays, the complexity of it with 270 miles of piping and everything. So when everything goes into the system, then it eventually ends up at the plant. And that's where we're going to go for this portion. And this is on the treatment process for I'm basically breaking it down into 3 stages. It's my doing, it's not necessarily Jimmy's doing, but he thinks it's acceptable. So when all this stuff goes through the system, Jimmy, and then it arrives at your plant, what happens there? What do you do the first part to deal with all this stuff that's come through the sewers?
Sure. So you can imagine nature itself already treats waste. If you let the natural cycle of life happen, you deposit waste on land, it eventually gets absorbed in the soil, and the whole process will naturally take place in terms of cleaning sewage. What we do at the treatment plant is take that same process and intensify it and do it a lot faster.
How do you do that?
So the way we do it is a series of treatment processes, as you mentioned, Tom. But in the basic concept, the whole idea of cleaning the sewage coming in is to remove all the solids that are in it, because the water is typically clear when you open your faucet, drinking water, and as you use the water and you use your toilet, you're essentially contaminating the water that you're flushing, that you're using. So at the treatment plant, we're removing all the contaminants. That's the whole idea.
The solids.
The
primarily.
solids. And how we do that is, in general, you let the heavy things sink and you let the light things float.
So you're using gravity.
Using gravity. And as they sink, we peel off, we'll suck it all out of the bottom of the tanks. Essentially, we call them primary clarifiers and secondary clarifiers. And you can imagine just the word itself is to clarify the water. You're cleaning it. You're getting it more clear. So we'll remove the solids, everything that settles out at the bottom, and anything that floats to the top, typically grease or oil, we'll have a mechanism that will skim it all off and also remove it from the water.
Now you have human excrement which goes in there as solids, and that goes down, right, or is expedited in terms of its dissolution. I don't know if that's the right way. And what are the problems you face in this process? When we had talked before, you mentioned something about things being put into the sewer system through our toilets in particular that shouldn't be in there. So tell us a little bit about what should not go in there and what type of problems this cause.
Sure. In general, we'll receive large objects such as 2x4s sometimes, or bed sheets, things like that. But in general, I think the major item that's a consumable is flushable wipes. That in itself is something that can wreak havoc on the equipment at the treatment plant. And I say that because there's the term flushable means different things to different people. Mm-hmm. And as a consumer, sometimes to me, for example, I go to the store, I pick up, I buy a bag of what they call flushable wipes. To me, when I read that, I think, oh, that just means I can put it in the toilet and it can go through my lateral without any issues. From a sanitary district's point of view and the operators and the mechanics over there, to us, flushable means that it's easily broken apart. And in general, a lot of the wipes out there don't break apart as easily as, say, toilet paper. Toilet paper, once you get it wet, it almost dissolves, right? It's mm-hmm. very easily breakable without much energy put into it, without much agitation. On a wipe, you actually have to give it some effort to tear it apart. And what that does is it clogs our pumps and causes issues at the treatment plant.
What about things like garbage disposals? Does what goes through that end up in your system as well?
It does. It does. And typically garbage disposal doesn't cause too many issues for us. The only issue that we deal with related to that is the grease.
Okay.
Yeah, so grease can be a potential problem, but we try to maintain our sewers as much as possible to keep it all moving. And I think one of the other challenges that we face at a treatment plant is flows. So how much flow do we get? So on average, our treatment plant will treat about 11 million gallons a day of wastewater. In a wet weather event, a big storm, sometimes will hit anywhere upwards of 60, 70, even though over 100 million gallons a day of water that we have to treat. And simply put, we're not designed for that kind of flow.
I never really thought about it right now. I think I'm probably like most of us in the public that just take things for granted. You flush the toilet and that's it, and we're fine there. In fact, a friend of mine was telling me recently, he's a contractor, and he said he had a lady at a home that they had built. The electricity went out and called him and said, "Will I be able to flush my toilet?" Because she didn't know there was no correlation there. But so when you flush your toilet, it goes down into the system in a house or a building or a commercial operation or whatever, and then it goes to sewer, but it needs motion, so it moves slowly, I assume?
It's all gravity. So there's a minimum slope that's prescribed in the plumbing code.
Oh, really?
Yes, and typically the idea is you want to make sure your water is moving at, hopefully, at least 2 feet per second. And that number is prescribed because that is generally the speed you need in the water to carry the solids with it. Because if it goes any slower, your solids will just end up sitting in your pipe as the water goes around it.
That's something I never knew, and I guess probably most of us don't know anything about that. So you have to have a certain angle going from the house or the building out to the sewer line.
To give you ideally a 2 feet per second velocity in the water.
Then how does it, when it gets into the main sewer line, how does it move there?
Same concept.
Same concept.
So we slope all our sewers a certain amount of degrees so that we try to get at least 2 feet per second of moving water.
Wow. So if it wasn't for people like Isaac Newton, we wouldn't figure all this stuff out right then in terms of gravity?
Right.
So we're still using, it's nice to know that gravity works, otherwise our sewer systems wouldn't work, right? Wow, that's interesting. So in that first stage, when the solids are removed, how effective is that? How much of the solids, so to speak, do get removed in that first stage?
Yes, Tom, the first stage of the treatment process is through the primary clarifiers, and they remove about 70% of the solids that come into the treatment plant.
And where does the solids go? You capture it, and where does it go from there?
Yeah, so on the solid side of the treatment, all the solids that get captured throughout the entire process gets thickened and put into what we call digesters, anaerobic digesters. And essentially what those digesters do are we take all the solids and they're consumed by bacteria that live in those digesters. Ultimately, the byproduct of the entire process on the solids processing side is to produce a stable, almost dirt-like consistency, what we call biosolids, that eventually end up, in our case, get land applied at a farm east of us and used as fertilizer.
Yeah. So where's that farm at?
Our farm, the farm that we work with, generally is in the Lodi area.
Oh, okay. So the solids, the heavy waste, then in essence become recycled in a way.
They get what we call beneficial reuse.
Beneficial reuse. That's a very diplomatic term. I like that. That's interesting. So, okay, that's the first treatment process, is getting 80-90% of the solids out. They're moved. They end up at a farm. The terms you use there for other purposes. Then the liquids, the water, the wastewater, goes to a second treatment process. Mm-hmm. What's the second treatment process like?
The second treatment process for us is what we call the aeration basins. And that itself is a large tank with bacteria in it, and we call them bugs, and they consume the waste that's still in that liquid stream. And we have a set of blowers that feed oxygen into those tanks so that those bugs can survive. They feed off oxygen and then the waste coming into that tank.
So do you put the bugs in there?
They cultivate on their own.
On their own. No, they're immaculate conception. Huh? They do. Wow.
Yes.
So then you said you put oxygen in?
Correct.
And how is that inserted in the wastewater?
So at the bottom of all these tanks, we have these large panels, similar size to, say, a fluorescent light bulb in your garage or in your kitchen, the long tubes. And they're panels with little pinholes poked, essentially perforated throughout that panel. And as you push air into the underside of that panel diffuses the air into little fine bubbles that eventually float to the top of the basin. Hmm. And as it's floating, there's an oxygen transfer happening between the air and water interface of each one of those bubbles.
And this all sounds to me like you're going to the moon again. All the complexity here, all the science, all the mathematics, and of course gravity applies going to the moon too, and one way or another. So is there, in terms of ongoing, all the scientific research, the technical research, the engineering, is there a national association or whatever of districts that continues to work on educational things, identifying new trends, new inventions, creations, so to speak?
Sure. There are a lot of nonprofit agencies out there. There are professional organizations, a lot of private companies who specialize in treating water and wastewater and performing design work for public agencies such as ours. Mm-hmm. And they typically, all of those entities, including us, a lot of public entities as well, try to stay on top of the latest technology as far as treating wastewater. And the ideal, essentially what the push is how can we do it faster, how can we do it more efficiently, and how do we do it with a smaller footprint?
Mm-hmm. Then So in this secondary stage, this treatment stage, before you move into sort of the final stage and then being put out to sea in the San Francisco Bay, so to speak, what's the water quality at the sort of the end of the second stage of treatment? Is before it goes in the is it getting there to like 95% or?
Sure. We typically, one component that we measure is called TSS. It's called total suspended solids. So you were alluding to that a little bit there, Tom, in the beginning, where you have the human waste coming down the pipeline, and in some cases it does get broken down. And when you break it down to really small particles, it kind of just dissolves or sits in the water and it floats around in the water, in the wastewater. And that's what we call total suspended solids. And that's measured in what we call the parts per million or milligrams per liter concentration. For frame of reference, you can imagine, we can use some round numbers here. The raw wastewater coming into the plant could be anywhere from 300 and 500 milligrams per liter of total suspended solids. At the end of the process, before it goes out into the bay, could be anywhere from 1 to all the way up to 15 milligrams per liter of suspended solids.
So in that third and sort of final treatment stage, which I call it anyway, is there any other things that are done in that particular stage before it goes into the final stage, which is to go out and you know, and for you in the audience, myself, I didn't know that all this ends up in the San Francisco Bay. Not only your district, but other districts. But that final treatment stage before it goes into this pipe, what's it like then, though? Is it
Yeah, Tom, the final stage is disinfection.
disinfection?
Disinfection.
And how do you disinfect it?
So essentially we use a solution called sodium hypochlorite, which is bleach. It's very concentrated bleach. And we dose that into the wastewater after almost all of the solids have been removed. Now you're left with a clear liquid, but we want to disinfect it and try to kill as many pathogens as possible that are still living in that water. And that's what the chlorine or the bleach, that's what it does to the water.
So at that point when, and this is running 24 hours a day, 7 days a week, 365 days a year, then the wastewater, the final product, goes into a big pipe that goes into San Francisco Bay. How far out does it go?
So that's a good question. I don't have the exact number, but it's at least, I actually don't know the exact number, but we distribute, discharge our effluent, we call it effluent, into a large pipeline to an agency called EBDA, East Bay Discharges Authority. And they own the common pipeline that goes out into the bay. And they collect wastewater effluent, clean effluent from 5 different treatment plants into one common pipeline that has a deep water discharge into the middle of the bay.
Yeah. And so all the sanitary districts in the San Francisco Bay Area use that same process. Everything eventually ends up into the bay. Is that correct?
In the bay, and except for some of the treatment plants on the peninsula, they have the luxury of having the ocean.
Oh. And then all these operations, these sanitary districts and sanitation districts operate under, they have to comply with state regulations and federal regulations as well?
Correct. The regulations come down ultimately from the EPA, but then it gets down to the state level where they're the ones that issue a effluent discharge permit to each of the treatment plants. And in those permits, they prescribe what essentially the maximum pollutant limits that you're allowed to discharge into the bay or into your receiving waters.
Well, you know, Jimmy, I find this rather incredible, to be honest with you. Like most people, I think, never think about what happens when you flush that toilet, where all this stuff goes and the system it goes through and then ends up ultimately in the plant that you manage, and then goes through all this sophisticated treatments, including using gravity, chemistry, everything, biology, and then eventually goes back into San Francisco Bay or the ocean. And it's as safe as it can be to allow us to have the lives we have, living in our homes and going to work and getting educations and things like that. To me, it's a rather incredible process that I haven't known hardly anything about, and that's one of the reasons why I wanted you to come on the show here, so others could learn about this incredible thing that happens out there for the public good and public safety and public health too. It's quite a story. Well, with that, we're coming close to the end of this interview and this discussion here, and I want to thank you, Jimmy, for coming on this show, and I hope you, the audience, have found the story to be interesting and Jimmy to be interesting, because I think it's, as Bill Nye, the science guy, says, the biggest breakthrough in improving human health in human history is getting control and developing sanitation capabilities and dealing with human waste. And it enables us to live longer lives and better lives and healthier lives as a result of this. So I want to thank you, Jimmy, and thank all the people that work with you for doing so much good for all of us in the public.
Of course, thank you,
Thank you
Tom.
for your public service, Jimmy.
Yeah, thank you.